Hi, this is question 3 from the AQA M3 June 2011 exam paper. We've got a golf ball that is hit from a point O on a horizontal golf course with a velocity of 40 meters per second at an angle of elevation theta. The golf ball travels in a vertical plane through O. During its flight, the horizontal and upward vertical distance of the golf ball from O are x and y meters respectively. We need to first of all show that the equation of the trajectory of the golf ball during its flight is given by this equation here. Now I've started off by drawing a diagram over here, and I'm just going to fill in that the speed here is going to be 40 meters per second at an angle of theta degrees. So this here is going to be theta degrees. Okay, I'm now going to write down a vector for my displacement. So I'm going to use the equation S is equal to ut plus a half of at squared. Okay, so over here I'm going to have my x and my y. Okay, so for my x, u is going to be 40 cos theta. So ut is going to be 40 t cos theta and plus half at squared, but we've got no acceleration horizontally, so that part is going to be 0. For my y, I'm going to have, well, u is going to be 40 sine theta, so ut is going to be 40 t sine theta. And this part here, half at squared, well, we're told that g is 10 meters per second, so that's going to be an acceleration of negative 10 because gravity is going to be acting in this direction. So half of negative 10 is negative 5, so that's going to give us, take away 5t squared. Okay, so this here tells me my displacement in my x direction and my displacement in my y direction. Okay, so over here for part A, we need to show that the equation of the trajectory of the golf ball during its flight is given by this equation here. So I know that x is equal to 40 t cos theta, and I know that y is equal to 40 t sine theta, take away 5t squared. Rearranging this to get it in terms of t, I will have t is equal to x over 40 cos theta. Okay, I'm now going to sub this into this here. So that's going to tell me that y is equal to 40 times x sine theta over 40 cos theta. Take away, and we'll have 5 times this squared, 5 times this squared, so that's going to be 5x squared over and 40 cos theta squared, so that's going to be 1600 cos squared theta. Okay, now simplifying this, I will say that, well, y is going to be equal to, the 40's will cancel each other out, sine theta over cos theta is tan theta, so this is going to be x tan theta, take away, and the 5 and the 1600 will become 1 over 320. So we'll have x squared over 320 cos squared theta, but 1 over cos squared theta is actually sec squared theta, so I'm going to put sec squared theta up here. Okay, so I'm going to multiply through by 320, so 320y is equal to 320 x tan theta. Take away, and sec squared theta, I want it in terms of tan squared theta. So sec squared theta is equal to 1 plus tan squared theta. So I can write this as x squared times 1 plus tan squared theta. And if I expand this and rearrange this, I'll end up with x squared tan squared theta. Take away 320x tan theta plus x squared plus 320y is equal to 0, as required over here, and we'll just put brackets around this bit that they've got over here. Okay, so that's part A done. We're now going to have a look at part B. So, let's draw a line here. Okay, for part B, the golf ball hits the top of a tree which has a vertical height of 8 meters. So, and is at a horizontal distance of 150 meters from O. So that what they're saying is that the horizontal distance, or x, is going to be equal to 150 meters, and the vertical height, or y, is going to be equal to 8 meters. Okay, so what I can do is I can sub this into this equation here. So I will have x squared, which is 150 squared. So 150 squared is 22,500 tan squared theta take away 320 times x, so 320 times 150, which is 48,000 tan theta, plus, and we'll have 150 squared, which is 22,500, plus 320 times 8, and all of that works out to be 25,060. Equals 0. Right, so simplifying this now, I can divide through by 20, so that gives me 1,125 tan squared theta. Take away 400 tan theta plus 1253 equals 0. Okay, what we've got now is we've got a quadratic. So I'm going to, obviously it will be quite difficult to factorise this, so I'm going to use the quadratic formula. So my A value is going to be equal to 1125, B is going to be equal to 2400. C is equal to 1253, and b squared minus 4ac, my discriminant, is going to be equal to 121,500. Okay, and I'm now going to plug this into my quadratic formula. So tan theta is going to be equal to minus b, which is this here, so that's 2,400, and it's going to be plus or minus, so I'll do the plus one first, so plus the square root of b squared minus 4ac, so the square root of 121,500 all over 2a, so all over 2 lots of 1,125, 50. And also tan theta is going to be equal to 2,400 take away the square root of 121,500 all over 2,250. So using this here, I can work out that theta is going to be equal to 50.7 degrees, and using this here I can work out that theta is going to be equal to 42.4 degrees. Okay, so for B part 1, which is what this was, I should put a part 1 there. The two possible values of theta are going to be 50.7 degrees and 42.4 degrees, and both of those starting values, or the starting angles of theta, would hit the top of a tree, which is a height of 8 meters and a horizontal distance of 150 meters from O. Okay, however, part 2, it explains to us that one of them is going to be, or both of these are going to be different times. They're going to take different times to hit the tree. So what we can do is, well, there's two ways of thinking about this. The shortest possible time is going to be the one that's going to be closer to the horizontal. So the smaller angle would give us the shorter time, but because we need to give a reason for our choice of theta, I think the easiest way of doing this would be to sub this back into this here. So we know that when theta is 50.7 degrees, we can work out the time. So time is going to be equal to and x is 150, so it's going to be 150 over 40 cos theta. So when theta is equal to 50.7 degrees, then time is going to be equal to 150 over 40 cos 50.7, and that gives us 5.92 seconds. And when theta is equal to 42.4 degrees, then time is going to be equal to, and I put 42.4 into theta here, and I get 5.07 seconds. Okay, and then we can say, well, therefore theta equals 42.4 degrees. It gives shortest possible time. Okay, and there you go. Hopefully that was clear and you found that useful. Thanks very much for joining me. I'll see you again soon. Take care.